Okay, so this is part 2 to 9.4 since I accidentally stopped the video early. All right. So for each of the following, blah, 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 I read it before, but identify the common difference, a recursive, an explicit, in the 10th term. So what is the common difference? Yep, your common difference is 5. What would be a recursive formula? Let's do a sub n equals, how would you write a recursive formula here? A sub n minus 1, term before it, plus 5. So just whatever the term was before it, plus 5. And then explicit. How do you write explicit for a sub n? What? What do I write first? What do I want the first term to be? So I should start with a 4 because I know I need my first term to be a 4, right? Then what do? Well, if I do plus 5n, then my first term is going to be 9. Is that what I want my first term to be? 5 times n minus 1. Remember that you have to do n minus 1 to zero out the first term. Please stop talking on the side. Does everyone understand why I have to do that n minus 1? Yeah.
Could you multiply that and adjust it?
You can multiply it. Yep. So if you wanted to think through multiplying that out, you can have 5 times the negative 1 is negative 5. Add that to the 4 is going to be negative 1 plus 5n. Yep. And some of you will even just jump straight to this. So some of you guys might look at the first term and be like, okay, go backwards one more, right? And then just do plus 5n. All right, so we've got our explicit formula. Which one is going to be easiest to use to find a sub 10? Which one? The explicit. So you can just plug in negative 1 plus 5 times 10 is 49, and then that's easy enough. Let's look at the next one. What's your common difference here? Negative 7? Right? What's your explicit formula for a sub n? I'm sorry, yeah, let's do recursive. Sorry, that's what I meant to do. So, recursive for a sub n. Okay, so a sub n recursively is going to be a sub n minus 1 and then minus 7, as easy as that. The explicit formula is going to be, how do I start it? With what I want the first term to be, minus what I want my common difference, but to cancel out the first term, n minus 1. And then I can use that, and you guys can simplify that. So if I were to simplify that, what would I have? 41, yep, 34 plus 7 once I distribute, and then minus 7n. All right, so to find a sub n, or a sub 10, we just need to plug in 41 minus 7 times 10, looking at our explicit formula. So 41 minus 70 is going to be 29, negative 29, right? All right, are there any questions on how to write and use formulas for arithmetic sequences and what the difference between an arithmetic and a geometric sequence is? Okay? So for this one, we have to do just a little bit more work. We want to find, for the given sequence, we want to find the first term and a recursive rule. How can I do this? Yeah, you're right. You're finding the slope, basically. You're finding, basically, how much did the value change in between those two terms, right? And then dividing that by how many terms were between 17 and 28, because that should tell you how much you added each time, which would be your common difference, right? So to do that, for the common difference, you take what your final number is supposed to be minus what you started with, and then divide that by how many terms elapsed in between, which is 28 minus 17. So these are both pluses. That means negative 73 plus 40 is negative 33. 28 minus 17 is 11. So my common difference is negative 3. Is there anyone who has any questions about why that's how we calculate the common difference? About why that works? Okay? So now that I've got the common difference, how can I find my recursive rule right now? Couldn't I? Just say that a sub n is equal to the term before it minus 3. Ariel?
Why did you put two pluses in front of the 40?
Because a negative and a negative is a positive.
Okay.
So I was just showing that it changes to addition. All right, so then I need to find a sub 1. How am I going to find a sub 1? What? So I think what you're trying to think through right now is that the first term is going to, or I'm sorry, we know the 17th term, and the 17th term should equal the first term plus 16 of our differences, right? Does everyone see that? To get to the 17th term. But I know that my 17th term is negative 40. And then negative 16 times negative 3 is negative 48. So to get a sub 1, add your 48 over. That means that your first term is 8. And we already did our recursive formula, right? And so we've answered both of the questions. Any questions on how to do that kind of a problem? If I give you two terms kind of in the middle of everything? Okay. So for the geometric sequence, this was the other one that we looked at, where there's multiplication to each term instead of addition. So that the number that you're multiplying by is called the common ratio, and we label it by R. So whatever the number is that you keep on multiplying by, that's R. So recursively, we can write it like this, or what did I say would probably be the better way? A sub n equals a sub n minus 1 times the r, right? And I might even throw the r in front, would probably be better. R times a sub n minus 1. I'm not sure why I wrote it that way in the first place, but I like the second way better. They're the same, though. Again, I mean, if you wrote it the other way, as long as it wasn't phrased, write a term for the nth term, then you'd have to do this way. But if they just said write a formula for a general term, technically that works as well. If you want to write it explicitly, this is your formula. This is the one that we already came up with. Remember on that slide with the negative 5 or positive 5, negative 15 alternating, where you put what you want your first term to be, what you're multiplying by, and then to the n minus 1. So again, that n minus 1 part is really key. You can't just do n. So let's take a look at how we can use some of this. So we want to, for the first one, keeping it simple, just identify the common ratio. That's all I want. What's your common ratio? Huh? 2. Very good. You're multiplying by 2 every single time, and that's it, right? For the next one, what's your common ratio? What are you multiplying by? Negative 1/2. Good. The negative because it alternates every other time. Sign, right? Any questions on that? Okay. So next thing I want to look at is finding the nth term or the 9th term here. Now you could just go through and multiply by the common ratio until you hit the 9th term, but let's try and come up with a better way for if I asked you for like the 40th term, you wouldn't want to do that method, right? So let's try coming up with a way to do this where I don't have to just multiply by the common ratio until I reach the number. What is, first of all, though, what is your common ratio? Root 3. Very good. You're multiplying by root 3 every single time, right? So what should I write to make finding the 9th term or any term be easy? The what? The explicit formula. So first I'm going to work on that. So what did we say the explicit formula is? The first term, which is 2, times your common ratio, which is root 3, and then to the n minus 1. Good. So there's my formula that I can use to find any term if I were to ask for it. So if I'm going to find a sub 9 using this, that's going to be 2 times the square root of 3 to the 9th. Now some of you are probably like, ugh, I don't want to do the square root of 3 to the 9th. It's really not too bad. Oh, yes, thank you. To the 8th because of the n minus 1, and I forgot about that for a second, right? So 9 minus 1 is 8. Thank you very much. So the way I like to think about this one is that it's 2 times root 3 squared to the 4th. And why did I do that? Because root 3 squared is 3. So I really can think about this as just 3 to the 4th. What is 3 to the 4th? 81, right? 9 times 9. And then 81 times 2 is 162. So that's my 9th term there. Any questions on that? Okay. All right, so for this one, we want to find a recursive and an explicit rule for each. So recursive rule should be pretty easy. It's just whatever the common ratio is times a sub n minus 1. So my recursive rule here starts out as a sub n equals, what's my common ratio? What am I doing? 1/5 times each of the previous terms, a sub n minus 1. And then my explicit is what we just did. So what should that look like? What? 25 times 1/5 to the n minus 1. Okay, now sometimes you can kind of simplify your formula a little bit if you can rewrite your first term as to look like the 1/5. So what I'm thinking is I can write 25 as 1 all over 5, all of that to the negative 2. Does everyone see that? So the negative would flip the 1/5 up to 5 and then square it is 25, right? Why did I do that? Because if you have two numbers that are the same with powers, what can you do? Combine them through addition, right? So I can write that as 1/5 n minus 3 instead, right? And that's a little bit cleaner. Yes, if you can, you should. Any questions on that? Okay, so let's take a look at the next one. What is your recursive rule here? A sub n equals, huh? Oh, yeah. So I'm going to put the 1 over x in front. But yes. So 1 over x is the ratio that I'm multiplying by every single time. And then times a sub n minus 1. Explicit. Some of you might jump right to the condensed form, but some of you might not. Do I really need to write a first term here? No, because my first term is already in the form of my ratio, right? So how can I write this one? Can't I just do 1 all over x to the n? Or, and this between these two, I don't care which way you write it. Wouldn't either of those work? You can do that whole write the first term times the ratio to the n minus 1 and then condense it. But here it's easy enough to see that, oh, well, my first term is the common ratio, so I can just go with it. Any questions on that? No? Okay. So now we have to learn how to graph a sequence using your calculator. Okay? I'm going to write a few notes up on here, and then I'm going to go ahead and do it. So the main thing that you guys need to do is go to your mode on your calculator and set it to sequence down on the 4th line. And then we're going to go to y equals for this thing right here. So we're going to set this to our y. It's not really going to be y equals, but that's the key we're going to press to enter that whole thing. So I'm going to lose all of this stuff that I just wrote, but they're simple enough notes to jot down. And I'm going to do it on the screen up here so you guys can follow along. So let me get to my TI-83. Okay. So on your calculator, like I said, the very first place that you need to go is mode. In mode, scroll down to where it says function, and we've already gone through parametric and polar, and now we're going to do sequence. Press enter on that, and then go to your y equals screen. You'll notice that it looks a little bit goofy, right? Okay, so we want to type in our sequence for UN. That's what they're asking for. So you're typing in 2 minus 1 over, and then n is the x key, but since it knows you're in sequence, it's going to give you n instead of x. Okay? Now, this u sub n min means what is the minimum value, or what is like when you plug in n min, which is 1, right? When you plug that into your sequence, what value do you get? So I'm getting for this 2 minus 1 over 1 is 1, right? So that's what I'm going to enter for my u sub n min. Okay, now go to your window for me. When you put n min is 1 and n max is 10, what does that mean? That you're only doing the first 10 numbers. So you should always start on 1, right? Unless I'm asking you to plot just like a middle part of the sequence. But then the n max is telling how many terms do you want to plot. So like 10 is fine for us. We'll go ahead and just do 10. But that's what that means. Okay? Plot start means started at 1, like x equals 1. And the plot step means every single time on the x-axis, every single integer then is going to be a point, right? So like if I set that to be, plot step to be a half, then every single, like the second term would occur at 1.5. Does that make sense? Yeah? So the plot start tells you where on the x-axis your very first term is going to be, right? So if I'm at the 5th tick mark on the x-axis, that means that that point is the 5th term in my sequence. Okay, so then I want to set my x min and my x max. X min, you kind of want to do a little bit of analysis on your function. So like I'm looking here and I'm subtracting a number, but I'm subtracting a fraction that's going to get smaller and smaller and smaller and smaller, right? Everyone see that? So is this ever going to get to 0? No. Well, this is actually for the y min, I guess I should be talking about. X min, I'm sorry, let me restart that. The x min, remember the x-axis is telling you which term you're at. So like if you start your x at 0, that's actually right before the first term, right? And then to 10 is going to plot up to 10 terms, which is all we want, right? So then scale down again. This is what I was just starting to talk about, and I got ahead of myself. But the y min and the y max talk about what values is this going to be between. So like I was just talking through, you're taking 2 minus some fraction that's going to get forever smaller. In other words, are you ever going to surpass 2? But are you going to get closer and closer to 2 because you're subtracting smaller and smaller numbers from it, right? So what should my y max be? You could do 2, right? That would probably be fine. It'll never reach 2, but it'll get closer. What do you want your y min to be? 0 is fine. Your y min will actually be 1, but I'm fine with plotting it at 0 so that we can see how high those numbers go, right? So now try plotting graph. And you'll see your points. Mine are kind of hard to see up here because they're little itty-bitty dots. But you should be able to see your first 10 points starting at 1 and then getting closer and closer and closer to 2. So that's how you plot a sequence. Are there any questions on how you do that? All right, so this is your homework. You have the rest of the hour to work on it, so you've got 20 minutes about. We'll do 9.5 on Friday, review on Tuesday next week, and then Chapter 9 test plus other stuff on, Thursday next week? Okay?